Okay, my people, let's start our lesson for today. So, you can see your, yeah, everybody keep joining immediately. Join immediately, cause we're about to start. We're about to get started. You're about to get started. Once you join, put yourself on mute so that the screen will not be disturbing us. Can you put yourself on mute? Um, um, Bright, please put yourself on mute. It's echoing back, and I can't hear what I'm saying. Bright, can you hear me?
Yeah.
Do your
Hello?
Bright. Are you calling from Cameroon? Are you a Cameroonian?
No, no, I'm not a Ghanaian.
You're a Ghanaian, okay. Can you mute yourself? Do you know how to mute? Can you put yourself on mute? On mute.
No.
There's a place
Okay.
that looks like a microphone. It looks like a microphone. You can put yourself on mute through that. So this is the platform we are using to learn educateafricans.com/courses. Once you go to educateafricans/courses, you're going to see all our courses. It's for the whole of Africans practicing for their WAEC, for their JAMB. This is where you need to be. You've got to be here. So you scroll down. Today we're going to be looking at chemistry, and it's important because these are you have the video and the textual part of the lectures, high quality lectures, and you enjoy it. Okay, so let me continue with this course. And this morning, before now, we looked at introduction to chemistry, advanced first. So check out the videos. So today we're going to be starting with nature of matter. The videos are explicit. They are very, very. Once you study them, you're going to understand everything. Okay. So let's start with
to conserve our forest. So
let's
all
start
the
with nature of matter. Very important. So we looked at everything. Okay, let me start with introduction, then I'll move straight to nature of matter. Let me go to introduction for those of us that didn't join earlier this morning. So you have to pay attention. Make sure you're in the WhatsApp group because we can start our classes anytime, any day. Like anytime, because we want to be able to hit our projectiles, our objectives. Okay, pay attention. I'll ask you a question after the class. Okay, this is educateafricans.com, the best place to
chemistry
learn.
is a pure science that deals with the composition, properties, and uses of matter. In our everyday life, we encounter chemistry, and that is why chemistry is very, very important for us to study. Chemistry is one of the pure sciences that we are supposed to study if we are to be writing WAEC, NACEP, or JAMB. The others are biology and physics. So why do we study chemistry? You have a palm wine. When the palm wine is freshly gotten from the palm tree, it tastes very sweet, but after some time, it sours. So what makes the palm wine to sour? Chemistry. You have a nail. A newly bought nail or a newly made nail is normally very shiny, but after some time, the nail gets rusted and looks exactly like this. What causes the rusting? Chemistry. When you're sick, you buy drugs, you take drugs. So, what are the elements or compounds that make up the drugs? So that when you take them into your body, they function effectively in order to make you to get well. The process of making these drugs is also chemistry. So there are plenty things in life, in our everyday life, that has to do with chemistry, and that's why we study chemistry. So as a way of introduction, we are going to be looking at the definition of chemistry. Chemistry is a pure science that deals with the composition. What are the makeup components of the drugs that we take? The chemicals that we use, the detergents. What is the composition? What are those elements that come together to make it up? Properties. How does these chemicals, how do the chemicals, how do they react? What are their properties? And uses. What and what can they be used for? So chemistry is a pure science that deals with the composition, properties, and the uses of matter. Matter is anything that has mass and occupies space, just like the chemicals that we're talking about. So now, in our everyday life, we encounter chemistry. So what are those things that happen in life that are actually chemistry? We'll talk about making palm wine sour, just like I showed you earlier. Rusting of nails, just like I showed you earlier. And drugs production, how you go about producing your drug. Also, the process of cooking our food, lighting matches, and burning of firewood. All these are chemistry happening in nature. So in time, we're going to be studying all these in details. And that is chemistry. So when they ask you in class, why are you studying chemistry? You study chemistry because you want to understand all these that happen in your everyday life. So in time, we're going to be studying all these. Why are you studying chemistry? You study chemistry because you want to understand all these that happen in your everyday life. And chemistry is a pure science because it goes through the normal process that every science, every pure science goes through in its study, such as observation, carrying out of experiment, formulation of hypotheses, formulation of laws, and taking down records. So all the processes that every pure science goes through, such as observation, carrying out of experiment, formulation of hypotheses, formulation of laws, and taking down records. So all the processes that every pure science goes through, such as
Okay, that's the first part. Let's look at matter. You can check through the curriculum so that you see other things, but we're going straight to matter and elements because we are getting serious. First part, let's look at matter. You can check through the curriculum so that you see other things. Test, heating, etc. Chemical properties are those involved when matter undergoes a change. Okay, so let's listen up. Matter is anything that has mass and occupies space. This nail I'm holding is a matter. It has mass, I can feel the weight, and it occupies the space. The drug that I showed you the other time is also matter because it has mass. Mass can be likened to weight, and it also occupies this very space. So anything that has mass and occupies space is matter. The palm wine, everything, even we human beings, we are all matter because we have mass and we actually occupy space. How do you differentiate one matter from the other? How do you identify matter when you see them? You can do that using their properties. Properties are those characteristics of matter that help you to differentiate one from the other. These properties of matter can be physical or chemical. The physical properties are those that are associated with physical change, such as boiling point, melting point, density, etc. Whereas chemical properties are those properties that are involved with the formation of new substances.
or new chemicals, as the case may be. Chemical properties are things like fermentation and roasting. Now, we are supposed to know the difference between physical change and chemical change. A physical change is one in which no new substance is formed and which is also reversible, whereas a chemical change is one in which a new substance is formed and it is not reversible. So those are the basics of the nature of matter. In subsequent classes, we are going to be looking at the forms in which matter can exist, either as an element, a mixture, or a compound. So as a way of getting down notes, we can say that matter is anything that has mass and occupies space. Example is the nail, palm wine, drugs, the examples that I've already shown you. In fact, almost everything that you can see around you can be called matter because they actually possess mass and occupy space. Now, we look at properties of matter. These are characteristics that substances possess which helps in identifying them. Now, you can actually differentiate between water and ethanol using their boiling points because they don't boil at the same temperature. Now, physical properties are those properties that are associated with the physical changes. Example is boiling point, melting point, density, hardness, color, odor, taste, etc. Chemical properties are those involved when matter undergoes a change to form a new substance. Example is roasting, fermentation, dissolution of metals and limestone in acid. Now, we have physical change and chemical change. All these are chemical changes: roasting, fermentation, and dissolution of metal and limestone in acid, because in each case, new substances are formed. So we say that chemical change is one which is not easily reversed and in which new substances are formed, whereas physical change is one which is easily reversed and in which no new substances are formed. So that is how we wrap it up on the nature of matter. In subsequent classes, we are going to be looking at elements, mixtures, and compound. And thereafter, we look at separating techniques. Please hit the subscribe button. Thank you.
Okay, so let's look at elements and compounds. Then finalize with separation techniques. Very important.
Matter may be classified as elements, compounds, or mixture. Elements and compounds are pure forms because they cannot be broken down into simpler substances, whereas mixtures are impure because they can still be separated. An element is a substance that cannot be broken down into simpler forms by ordinary chemical process. Example of an element is oxygen, the one we breathe in, hydrogen, sodium, sulfur, potassium, all the elements that you know, and there are about 109 elements. Compound constitutes of two or more elements chemically bound together. Example of a compound is water, consisting of two elements, hydrogen and oxygen. Another example of a compound is hydrogen chloride, HCl, consisting of hydrogen and chlorine. Mixture constitutes of many substances that can be separated using physical processes or chemical processes as well. Examples of mixtures are blood, urine, the milk you take, the air that you breathe in, consisting of oxygen, nitrogen, and the rest of them. The blood. As a way of taking notes, we are going to be looking at this. Elements, compounds, and mixtures. Matter may be classified as elements, compounds, and mixtures. An element is a substance which cannot be split into simpler units by an ordinary chemical process. Example is oxygen, hydrogen, etc. And there are about 109 known elements. Elements are actually in pure form because they cannot be broken down into other elements. A compound is a substance which contains two or more elements chemically combined together. Example is H2O, which is water, and HCl, which is hydrogen chloride. Note that the properties of the constituent elements, let's say for hydrogen, for water, the property of water, H2O, is very different from the property of hydrogen separately or oxygen separately. Just like HCl, this is an acid, it's corrosive. The property of this acid is very, very different from the property of the hydrogen differently or the chlorine differently. Now, a mixture contains two or more constituents which can easily be separated by physical methods. In subsequent classes, we are going to be looking at separation techniques. We are going to find out that we actually use separation techniques to separate mixtures. Examples of mixtures are air, soil, urine, palm wine, Coca-Cola, milk, blood, crude oil, brass, seawater, etc.
Okay, so let's look at separation techniques. It's very important. Separation techniques is so important. And after this, you're going to write quiz and
Separation techniques. Separation techniques are those methods that we use in separating the constituents of mixtures. The individual constituents of mixtures behave differently. They have different properties. They retain their respective properties. So if you have a mixture like crude oil, in Nigeria we have lots of deposits of crude oil. The constituent part of the crude oil can be separated so that we can have the PMS, we can have the diesel, we can have the fuel that the aeroplane use. So how do you separate this mixture of crude oil in order for you to get the fuel, that the petrol that we use for cars, the one that airplane use, and the diesel for diesel engine? We use what we call separation technique. And the separation technique used here is fractional distillation, considering the boiling points, because the boiling point of PMS is different from that of diesel and is different from that of the AGO. So due to this difference in boiling point, which is a physical property, we can easily separate. Now you buy your rice from the market. You have stone inside the rice. Some of our locally made rice, you have stone, then you have your rice. You can easily use sieving because of the difference in size of the stone and the rice. If you have beans, also difference in size between the seeds of the beans and the stone. So there has to be physical property that can easily differentiate one constituent of a mixture from the other for you to be able to separate them into two. We have different separation techniques, and these separation techniques are actually used for specific kind of mixtures. So what are these kind of mixtures that need these various separation techniques? The separation techniques that we have are sieving, filtration, decantation, crystallization, fractional decrystallization, distillation, fractional distillation, magnetic separation, chromatography, and the rest of them. Now we are going to be looking at a particular mixture and the suitable separation technique used. Sieving. When you have solids of different sizes, like in the sand of different sizes, you have to sieve. If you want to collect specific sand side of a specific from the other one, you have to sieve it out to get the size that you need. If you have your rice and it's contaminated with stone, and the stone and the rice have different size, and you want to sieve out, you want to separate, you use sieving. Magnetic separation is used whenever you have magnetic solids and you want to separate them from non-magnetic ones, as in steel. So whenever you have metals that are magnetic and you want to separate them from non-magnetic ones, you use magnetic separation. We have decantation, filtration, and centrifugation. And these techniques can be used to separate insoluble solid from a liquid. So whenever you have insoluble solid, a solid that cannot dissolve in a liquid, you can separate it from the liquid using either a decantation, filtration, or centrifugation. You also have evaporation, crystallization, precipitation, and fractional distillation. And these techniques are used to separate soluble solid from a solution. When you have a soluble solid, that means solid that can actually dissolve in a solvent. If you want to separate them, then you use these, either evaporation, crystallization, precipitation, or fractional crystallization. Now you have another technique known as distillation, which is used to separate solvent from its solution. You also have fractional distillation, which is used to separate miscible liquids, just like we have in crude oil. We also have separating funnel, used to separate immiscible liquids. And we have chromatography, that is used to separate solids from a solution. So how do these questions come out in WAEC or JAMB or NICO? You're going to be asked, which of the following methods can be used to separate solids of different sizes? And you have options: sieving, magnetic separation, decantation, and filtration. You are supposed to pick sieving. They're also going to ask you, which of the following separation techniques can be used to separate solvent from its solution? You should know that it is distillation. Now, if you have substances that are impure, to get them to be pure, you used to use separation techniques to separate them, to separate the impurities from the main substance. So how do you test for purity? How do you know that a substance is pure? What can you use in checking to know that this substance is pure, that the proper separation has been done? Test for purity. There are two major ways of testing for purity. Either by using the melting point or boiling point, or by using the chromatographic characteristics of the substance. Now, impurities make substances not to boil or melt at the specific temperature that they should, as it's written in the book. Actually, impurities decreases the melting point and also increases the boiling point for liquids. Impurities decreases the melting point for solid and increases the boiling point for liquids. So, for you to know whether a solid is pure, when it melts below the temperature that it should have melted, then you know it is impure. Whereas that of a liquid, it will now boil at a temperature that is higher than the normal boiling point. Also, in a chromogram, a pure substance produces a single spot, unlike substance. So that is how you test for purity. So to make impure substances to be pure, they need to undergo purification using any of these separation techniques.
Okay, that's interesting. I hope you're dropping your questions, and I think to wrap it up, to wrap it all up, let's look at the quiz to wrap it all up. Well, we can also check out particulate nature of matter. Okay, please check out the quizzes and see what you can. This is from WAEC 2017 chemistry. You can see the question and you can see clear explanation of the answers. You can see test for purity for solid, very important. You can see a sample or separation technique problem, very important. These are from your WAEC and your JAMB. You need to check them out with answers. They are all with answers. The question, then the answer with explanation. Check them out, check them out, check them out. So this is the platform to use. You can see the way we are moving. You can actually learn a whole lot. So let's get to the next problem, next topic. So follow them out. It's well explained. And you can actually download our app from Google Play Store. Just go to Google Play Store, search for Educate Africans. Educate Africans. That's where to be. That's what to download, and that is how you move forward. Okay, if you have any questions, drop them in the comment section. I'll always do well to
We
attend.
can have molecules, we can have ions.
Okay, so let's listen up.
Matter is made up of discrete or small particles, which can either be atoms, molecules, or ions. So matter, like me, you, the drugs we take, the food, anything around us that has mass and weight, is actually made up of discrete or small particles. And these particles, we can have what we call atoms, we can have molecules, we can have ions. Atoms, or an atom, is the smallest part or particle of an element that can take part in a chemical reaction. You can have an atom of elements like phosphorus, an atom of sodium, an atom of calcium. Now, a molecule is the smallest particle of a substance that can actually exist alone and still retain the properties of that substance. You can have a molecule of hydrogen. An atom of hydrogen is written as H, whereas a molecule of hydrogen is written as H2. H subscript 2. Now, what is an ion? An ion is an atom or group of atoms that possess an electrical charge. Now we're going to look at these concepts one by one. So we are looking at the particulate nature of matter. How matter is actually made up of small particles. These discrete small particles can either be atom, molecule, or ion. Now, an atom is the smallest particle of an element which can take part in a chemical reaction. You can see this is phosphorus atom P, this is sulfur atom S. But now, if you have phosphorus that can stay alone, this might not be alone, it will be in the presence of other atoms. But now you have this P4. This is 4 atoms. It has an atomicity of 4. 4 atoms of phosphorus that are together. They can exist alone. We call it molecule. So a molecule is the smallest particle of a substance that can normally exist alone. Very, very important. Atom might not be able to stay alone, but molecules are able to exist alone and still retain the chemical properties of that very substance, be it element or a compound. Example is neon. Neon can stay alone with the atomicity of 1, just having 1 atom. Argon, hydrogen, nitrogen, phosphorus, sulfur, the sulfur molecule, oxygen molecule, and ozone molecule. So all these are molecules. They can have more than 1 atom, but the atoms just have only 1 atom. Very, very importantly. Now we look at ions. An ion is an atom or group of atoms which possess an electric charge. If this charge is positive, then we'll call them cation, or we'll call it cation. But if it is negative, we'll call it what? Anion. So these 3 are the basics. Please make sure you get out the notes. Get out the notes so that you can easily understand in future when you go through it. Now, these 3 are the major discrete forms that matter can exist in. Very, very important. Atomicity is simply the number of atoms in one molecule. Like here now, the atomicity here is 4. Atomicity here is 8 because there are 8 atoms in one molecule. All these are molecules. But atom, the difference is that atom is just 1 single atom. But for molecule, it could be more than 1 atom. And these molecules can exist alone. You can see them in nature alone, unlike what we can have here. Whereas ions are actually charged. They are charged. So you can have something like this, Ca plus. So you can have something like Na plus. This is single positive charge, double positive charge. So all these are ions. Because they are positive, they are called cations. So example of anion is chlorine with negative charge. Non-metals are mostly anions. Non-metals are mostly anions. Non-metals are mostly negatively charged, whereas metals are mostly positively charged. So these are the 3 discrete particles that matter is made up of. Subsequent classes, we are going to be going into details of how to use these and understand them much better.
Okay, that is that. That is that for the discrete particles of matter. Discrete particles of matter. Very, very important. Now let's before we wind up for today, let's look at Dalton's atomic theory. That'll be the last for today. Very important. You need to understand what the stipulations of Dalton's atomic theory. You need to know the stipulations of Dalton atomic theory. It comes out in WAEC like on a daily. It comes out on a daily. So you have to just get a grasp of Dalton's atomic theory, both the modification, the initial stipulations, and the modification. Let's take a listen.
John Dalton in 1808 helped us understand more about atoms, and he put forward the Dalton's atomic theory. This Dalton atomic theory over the years have undergone several changes and modifications because some of the statements through experiments have been proven to be wrong or cannot hold completely. So now we're going to look at the statements of the Dalton atomic theory, and at the same time I'll be mentioning or pointing out the modification or the modifications that have been done on these statements. So let's look at the first statement of Dalton's atomic theory. All elements are made up of small, indivisible particles called atoms. Is this true? Yes, because all elements are actually made up of atoms, small atoms, but that these atoms are indivisible. Now, through the experiments of people like Rutherford, we're able to know that atoms are actually divisible. Atoms are actually made up of protons, neutrons, and electrons. So whereas the first part is true, the second part is not true. So this used to be very correct, but because of several experiments that have gone through in recent times, we are able to find out that atoms are actually divisible. Number two, atoms can neither be created nor destroyed. This still holds true for ordinary chemical reactions. But we know that in nuclear reactions, things like uranium can still be broken down into other atoms of other elements. Now, so this one, nuclear reactions, makes this very statement to be not completely true. Here, the discovery of electrons, protons, and neutrons made this not to be completely correct. So these are the modifications.
Please, can you put yourself on mute? Favor pausing. Be on mute. Thank you.
Now, thirdly, we have that atoms of the same element are alike in every aspect and differ from atoms of all other elements. This is not completely true because of the discovery of isotopes. Now, in isotopes, we find out that one element, say chlorine, can have different isotopes. They can have the same chemical property, but the mass number will not be the same. So this is the modification to this. Now, when atoms combine with other atoms, they do so in simple ratio. This is actually correct for inorganic reactions. The combination between the combining atoms, different atoms, for inorganic reaction can occur in simple ratios. But when you have complex organic reactions, like that involving proteins or other things in organic chemistry, there is no simple ratio combination. You can have them in multiple ratios. Now we have the fifth statement of the Dalton atomic theory. All chemical changes result from the combination or separation of atoms. I think this still holds true. So these are the statements of the Dalton's atomic theory. And these are their modifications. So these modifications were born out of experiments that have been conducted since after Dalton in 1808. Since after John Dalton in 1808 put forward the following statements. Much of this statement Much of these statements have already been supported by things like the law of multiple proportion, the law of conservation of mass, and other laws. So in subsequent classes, we are going to be using those laws to do a lot of calculation and other inferences. Thank you.
Okay. So please, you're gonna check out the assignments, the quizzes, and get yourself updated. Do the quizzes, do the test, do the assignments, and drop your questions in the comment section. No matter where you're following, if you're joining live streaming on Google Meet, drop it in the message section. If you're joining from our YouTube, drop it in the comment section. If you're joining from Facebook, drop it in the comment section. And you need to join the WhatsApp group. That's where I mark the assignments. So just send me hi on WhatsApp. Tell me to add you to the group. My phone number is +234 70671 626 98. Okay. So make sure you get added to the main thing. Okay. Download our app from Google Play Store. Just go to Google Play Store and type in Educate Africans. Okay, this is the name, Educate Africans. You're gonna see our app there. So this is my phone number. This is the website, and you can also download from this website. This is my phone number here. So check out the number, call, get added. I can also send you a flash drive that has all our lectures and past questions so that you can stay at home in your phone. With your phone, you can just plug it in your phone. You practice. So you can. This is the life changer summary for JAMB, summarized by us here. Very, very descriptive. This is your JAMB syllabus if you want to know what to read. This is the CBT app. If you want to have your CBT app for desktop and the one for phone, Android phone. Okay. Even the WAEC CBT app as well. You can join our YouTube, LinkedIn, Facebook. Connect with us so that anytime we are live streaming, you'll be the first to see our live streams. Okay, so you can check out our subject once you click on view our courses, or once you type educateafricans.com/courses, you see all the subjects that we've treated. Most of your WAEC courses, programming, website development, that is what we teach Africans. Okay, so check it out, see the ones that concern you, and start taking lectures so that you get ready for me any day I want to teach you. I want you to have gone into this platform and learned a whole lot so that when we now learn, everybody's on the same page. Okay, so when I see you again, for those of us in the WhatsApp groups, I'm going to be sharing the timetable, the tentative timetable that we'll be using. Pending the time, we'll change it. So I'm going to be sharing that timetable. I'll also put it on my Facebook, YouTube, and LinkedIn. So if you're following me on any of those, then you're going to see those timetables so that you can follow up. So we're taking time to build it so that we know that we can cover the maximum amount of students that we have at hand. Okay, that is the plan. That is the plan. Okay, educate Africans. That is where to learn from. Okay, now see you until I see you. Do well to go to chemistry and check out the assignments there. Do them. Okay, please, I want you to give me 6 examples of compounds and 6 examples of mixtures, and list out the various separation techniques and the reason for their use. So that is the assignment. Submit it on WhatsApp. Everybody submit it on the WhatsApp channel. You can also submit on any of the channels that you're watching within the comment section. Drop it on the YouTube comment section. See you when I see you. Thank you. God bless you.